So what we're going to be doing today is we are going to be revolving around other axes. Okay, so not the x-axis or the y-axis. They will still be horizontal or vertical. It could probably be done to rotate it around a slanted line, but I have no idea how to do that, and we definitely are not going to be required to do anything of that nature. So a couple of notes here. If you are rotating about a horizontal line, it is still going to be pi integral from A to B of capital R of x squared minus lowercase r of x squared dx. Be in terms of x if you're rotating about a horizontal line. Okay, so even though it's not going to be the x-axis, it's going to be a horizontal line that is moved up or down, you're still going to use that same formula. It's just going to be what your capital R of x and your lowercase r of x are is going to change a little bit. Okay, and if you're rotating about a vertical line, then you will have basically the same formula, but it will be in terms of y. I should have an extra set of parentheses there. I just use different letters. Yeah, C to D. Different letters because they'll come from the y-axis instead of the x-axis. Oh, wait. That should be a y right there. All right, so this question says, find the volume of the solid generated by revolving the region bounded by f of x equals 2 minus x squared and g of x equals 1 about the line y equals 1. So keep in mind, horizontal lines are y equals. Sometimes we get tricked up with that, but y equals is a horizontal line, not a vertical. So this time we are taking this area right here, and we are rotating around this line, not the x-axis. Will this figure have a hole in the middle of it? It will not. If you rotate it around the x-axis, it would have a hole in the middle of it. But around the line y equals 1, it does not have a hole in the middle of it because it just lines up with the, it actually touches the line that it's rotating around. Okay, so in this case, when you don't have a hole in the middle, it's really like a disk method. Your lowercase r of x is going to be 0, and we'll see that here in a second. So our capital R of x is whatever's furthest away from the line that we're rotating around, and that we really want to kind of go with that idea rather than top minus bottom, because sometimes it's not top minus bottom for this, depending on what line you're rotating around. For x-axis, you can pretty much always do that, but for this, you're going from the line you're rotating around to the equation that's furthest away. That is your capital R of x. Now, that capital R of x here is going to be wherever the top of that line is at minus wherever the bottom of that line is at. Okay? So the top of that line is on the curve that is 2 minus x squared. So that is going to be 2 minus x squared. But this doesn't go all the way down to 0 like it has on everything else we've done so far. Right? Every other time our capital R of x went all the way to the x-axis or all the way to the y-axis where we had a 0. So right here, this line is stopping at 1, right? If I haven't, like, for example, if I plug in 0 right here, I'll get 2. But the length from here to here is just 1. You got to subtract out that 1. So we're going to subtract 1 from that. Now, on a problem where you are up next to the line you're rotating around, what's your lowercase r of x going to be here? It's not 1. It's going to be 0 in this case. So if the region touches the line of rotation, lowercase r of x is just going to equal 0. Because that lowercase r is like the radius of the hole, right? The part you're subtracting out, and there is no hole in this, so it's just 0 for that. So really, you could really do these like there is no lowercase r of x on these problems, but I kind of wanted to set it up this way so it also works for when we do have a hole. So let's simplify down our r of x just a little bit. I've got 2 minus x squared minus 1, which is going to give me 1 minus x squared. And so I will need to integrate pi times my capital R, 1 minus x squared, in terms of x. I don't have to do minus the lowercase r of x because it is 0. There's no hole in the middle of this. What should my limits be on my integral? -1 to 1, because those are the intersection points of our region right here. So -1 to 1. And we'll do this one by hand, but we're going to do most of these either just set up or use our calculator. Let's pull the pi out. That's going to be 1 minus 2x squared plus x to the 4th dx there. And like I said, we'll do one of these by hand just so we're not out of practice, but most of these we won't just for the sake of time. So this will give us x minus 2/3 x to the 3rd plus 1/5 x to the 5th from -1 to 1. And then that will give us pi 1 minus 2/3 times 1 cubed plus 1/5 times 1 to the 5th. I don't know why it's being so hateful today. And then -1 minus 2/3 times -1 to the 3rd plus 1/5 times -1 to the 5th. And that is going to be 1 minus 2/3 plus 1/5 minus -1 plus 2/3 minus 1/5. This negative needs to be distributed, so that's going to be 1 minus 2/3 plus 1/5 plus 1 minus 2/3 plus 1/5. Gosh. And so 2 minus 4/3 plus 2/5. Let's get common denominators. So that'll be over 15, 30 over 15 minus 20 over 15 plus 6 over 15, which is going to be 36 minus 20. So I think we will get 16 pi over 15 for our answer if I have not messed up there. this one. That negative 1 to the third is a negative 1, and so negative 1 times that negative 2/3 becomes positive. Same thing happens there on your 1/5. That's going to be a negative 1, and then it'll change the sign right there. But then it changes back because you got to distribute the negative. So hopefully I've done that right. Again, setup is what I'm most concerned with. A lot of times they don't even ask you to solve these. So our capital R of x was the equation for the top, right here, which is 2 minus x squared, minus the equation for the bottom, which is just 1. So when I do 2 minus x squared minus 1, I can just subtract 1 from that 2, and I'll get 1 minus x squared there. So that is your outside radius. All right, any other questions? Yes. G of x equals 1 is like y equals 1. That's a horizontal line at 1. So it is that green line that we have right there. Okay, questions? Let's try another one. We may not do all of them. Well, we're definitely not doing all of them here. All right, let's do a vertical line. Okay, so for this one, we have the volume of the solid generated by revolving the region bounded by y equals x minus 3 to the third, y equals 8, y equals negative 1, and x equals 1 about the line x equals 1. So we are looking at, it thankfully has it graphed for us already here. We are looking at this area right here, and it is being rotated around x equals 1. This is x equals 1 right here. So, for this, is it going to have a hole in the middle of it? It is not, because whenever we rotate around, our figure touches the axis that we're rotating around the entire length of the section that we're looking at, right? So whenever you have that, area right up next to the area that you're or the line that you're rotating around, your lowercase r of x doesn't really exist. It's just 0. There is no hole in the middle because that lowercase r is for the whole part of the function. So we really only need a capital R of x. So my capital R of x, this is a vertical line. Actually, we do not need a capital R of x. What do we need? R of y. Okay? It needs to be this horizontal piece right here that gets rotated around that axis, right? That's our capital R of y. That is going to be whatever is furthest to the right on that line minus whatever's furthest to the left. You can think about where the endpoint of the radius is and where the other endpoint of the radius is. Now, one thing we've got to do first, this isn't in terms of y right now, it's in terms of x. So we're going to have to first, before we can even talk about this, solve that for our x. So I've got y equals x minus 3 to the third power. How do I get rid of something to the third power? Cube root it or 1/3 power, whichever one you want to use there. We'll cube root. So I've got cube root of y equals x minus 3, and then I need to add the 3. I'll put the 3 up here. So actually, I am going to do y to the 1/3 instead of cube root. It's easier to type in the calculator with a y to the 1/3, and I'm going to use the calculator here. But you can do a cube root if you would rather. So this purple line right here in terms of y is 3 plus y to the 1/3, or y to the 1/3 plus 3, whichever way you want to write it. And the blue line right here is x equals 1. So put x equals here. So to set this up for our capital R, it needs to be the end point right here that's furthest to the right is on that purple line. So that is 3 plus y to the 1/3. But we've got, it doesn't go all the way to the y-axis. If we just put that, it would go all the way to the y-axis. We got to subtract whatever number we have on the other side right here, which is our x equals 1. So it's just going to be a 1 right there. And so if we want to combine that, our capital R of y is going to be 2 plus y to the 1/3. Questions there? Yes. Say that again. Be a little different if it was 5. We'll look at that on the next part though. Because if it was 5, it would be over here. So your furthest away would be like 4. Yeah. Yeah, it would be 5. If the whole thing was shifted to 5, yes. Yeah. So that is our capital R. We need to and our lowercase r is just 0, so we really don't have an inside part. So we're going to integrate pi times that capital R squared, put dy over here, and we are integrating. What are our limits? -1 to 8. Looking at our y-axis, the lowest we go right here is at -1. The highest we go up here is 8. And we're going to use our calculator for this because we just do not have time to do all of this by hand. All right, let's see. So if we do integrate pi times 2 plus y to the 1/3 squared, comma y, comma -1, comma 8. Please work. Are you guys getting 504 pi over 5? Yeah. You could do it without the pi. You put the pi on the outside. You can put the pi on the inside. You can leave the pi out altogether as long as you remember to put it back into your answer at the end. Make sure you're like squaring this whole thing, 2 plus y to the 1/3 squared. Make sure it's not just the y that's getting squared there. Try to help your neighbors if they're struggling. Get it? Right. All right. For sake of time, we are not going to do this one. We're going to skip to the next part, which I need to open another. I've got to open 12 here. Mine are separate. All right, and let's actually do 2 where we've got a graph for us there. Make it a little bit easier. We might come back and do one on just the side. All right, so region R is bounded by y equals x, y equals 3, and x equals 0. Find the volume of the solid created by rotating region R about the line y equals 4. So are we rotating around a horizontal or a vertical line? Horizontal, right? Y equals 4 is a horizontal line. So let's graph what we've got here. We've got y equals x is just our line that cuts the first and third quadrants in half. So that's y equals x. We've got y equals 3, which is going to be a horizontal line at 3. And we've got x equals 0, which is our y-axis. And so we're looking at this region right here. And we are rotating around y equals 4, which is going to be, I'm going to use a dotted line right here because this is, that is y equals 4. Okay, so we're taking this and we're rotating it around that line. Will we have a hole in the middle? We will have a hole, right? Because this region does not touch the line we're rotating around. Okay, so this is where I said it's kind of important to think furthest away from the line and closest to the line when you're doing your capital R of X and your lowercase r of X. Because it's not going to be top and bottom this time, where our line that we're rotating around is above our figure. It's going to be a little bit different. So our capital R is going to be from the line of rotation down to that outside line, right? That is your capital R of X. And we're going to be in terms of X because we're rotating around a horizontal line. So capital R of X. Now, to figure out what that is, you want to take wherever the top dot is on that vertical line. That is what goes first. Where is that at? 4 is y equals 4. So we put 4 minus. Where's the bottom dot at? It is a 1 here, but like the top dot, even if we move this like left or right, it would stay on 4. This one would move, right? It is on the red line, which is y equals x. So it's going to be x right there. Okay, that is our outside radius. If you think about it, like when you're over here for your like biggest piece, when you rotate that around, the radius right here would be 4, right? But over here, it would just be 1. And everywhere in between, this will give us that. Okay? Now, our inside radius is from the line that we're rotating around to the closest one. That is our lowercase r of x. Now, that's going to be constant the whole time, right? Because if I slide this left or right, it's the same everywhere. Again, you can do the top of that line. Where's the top of that line? 4 minus the bottom of that line. Where's the bottom of that line? Is it 3? Okay? So, because this is y equals 3 right here. So it's just 4 minus 3, which is just going to give you 1, right? And it's constant. You don't have a variable there because they are just two horizontal lines. That whole part is going to have the same area the whole time, or distance the whole time. Okay, questions there? All right, so now that you've got capital R and lowercase r, you're just setting it up like you were yesterday, right? So it is, you can do it with separate integrals, you can do them together, it doesn't matter. If you do it separate, it'll look like this. Pi integral, what should limits be? 0 to 3, because we're still looking at our x-axis, because we're in terms of x, right? So we look at our x-axis, they intersect over here at 0, and then the last point's over here at 3. So integral from 0 to 3 of 4 minus x squared. You can put the pi on the inside or the outside. Minus pi integral from 0 to 3 of lowercase r, which is just 1 squared dx. That would be what it would look like if you do them separately, pi r squared minus pi r squared with the integrals in there. A lot of times you'll see them together. They'll put the pi out front. You'll have 0 cubed, and then you'll have 4 minus x squared minus 1 squared, which is just 1 dx. And this one's not that hard to do by hand, but we just don't have time for things like that, so let's just use our calculator. I'll do pi integral of 4 minus x squared minus 1 squared, if you want to put it, but you don't have to do that, comma x, comma 0, comma 3. And I'm getting 18 pi. Is that what you guys are getting? Okay. If you get your capital R and lowercase r, it's not a lot different than yesterday, but the capital R and lowercase r is the hard part on this for sure. All right, here's another one. This one's going to be vertical. Okay, so example 3 is the region in the first quadrant bounded by y equals x minus 2 minus x, y equals 2 minus 2x, and it's revolved around the line x equals 3. And I don't know why I put this graph like I did. Because it's in the first quadrant. I don't know why I did that, but let's see. Let's just see what it looks like. Yeah, it's like you need to be in the second quadrant, but I think that I just made a silly graph there. All right, so 2 minus x is going to have a y-intercept at 2 and a slope of negative 1. And will look like this here. And 2 minus 2x, I about think I need to go make a new graph for this one. You guys don't have a good one either. Down 2 to the right 1, it would look like this. Oh, oops. That point will be right there. And it tells us first quadrant. So first quadrant means we're looking at just this little sliver right here, and I don't know why I made my graph look up like I made it look right here. Okay there. All right, what are we rotating around? X equals 3. So x equals 3 is a vertical line at 3. So it's this line right here that we're rotating around. So when we're setting up outside radius, okay, Again, at this point, we need to be thinking furthest away from the axis that we're rotating around and closest to the axis that we're rotating around for our capital R and our lowercase r. Which one of those graphs is furthest away from the axis we're rotating around? Yes, the 2 minus 2x, that green graph right there. So that would be our capital R of x. Or, well, actually, no, not capital R of x. What should we be doing? Capital R of y. So we need to make them equal to y. So if we take this green one here, y equals 2 minus 2x, I'd need to subtract 2. Y minus 2 would equal negative 2x. I'll divide everything by negative 2, and I will get negative 1/2 y plus 1 for my x. So this green graph, we don't want to think of it as y equals 2 minus 2x. We want to think of it as x equals negative 1/2 y plus 1. We need to do the same thing with that red graph. It is going to be y equals 2 minus x. We will subtract that 2. Y minus 2 equals negative x. Divide everything by your negative 1. You'll have negative y plus 2 equals x. So this graph right here is x equals negative y plus 2. Okay, so what we want to do for this, when you're going left and right, the right point needs to be the greatest, the left point would be the smallest, right? So just like we were doing top minus bottom on our capital R of x, we will do right minus left. So if I look at that line I have there for my R of y, capital R of y, the end point furthest to the right is right here. Which line is that on? X equals 3. So that's going to be 3. The right side is on 3. What's the left side on? Half y plus 1. Half y plus 1. Now, I would simplify this a little bit just to make it easier to type in. I would distribute here. That'll give me 3 plus 1/2 y minus 1. And then I could combine the 3 and the negative 1, and I'd get 2 plus 1/2 y as my capital R of y. I'm going to stop there for a second because I think that's the hardest part. Questions? Okay. For our lowercase r, because this will have a hole in the middle of it, right? If it's going to have a hole in the middle of it whenever you rotate it, it's going to have a lowercase r. If it has no hole, it has no lowercase r. So for our lowercase r, that is from our axis of rotation to the graph that's closest. That's our r of x, right? Our lowercase r of x. So to set up our lowercase, no, not x, what should I have? Y. All right, lowercase r of y. What is furthest to the right on that line? X equals 3, so we're going to put the 3. What is furthest to the left on that line? Negative y plus 2. So we got minus negative y plus 2. And that will be 3 plus y minus 2. And we can just write our lowercase r of y as 1 plus y. We okay here? All right, once you get this, when you've got your capital R and you've got your lowercase r, it is pi capital R squared minus pi lowercase r squared, right? So to set this up, we would have the integral of pi capital R, which is 2 plus 1/2 y squared. What would our limits be on that one? 0 to 2. And then we would subtract, same limit, 0 to 2, pi inside radius 1 plus y squared dy. A lot of times you'll see this put together. So if it's put together, the pi can be pulled out front. Just use one integral, and you'll have 2 plus 1/2 y squared minus 1 plus y squared dy. And let's use our calculator for that. So pi integral of 2 plus 1/2 y squared minus 1 plus y squared, comma, y, comma, 0, comma, 2. Oh gosh, mine's just my calculator's broken. I'm hitting the back and it just keeps putting a 0. Look, now it's just changed it all together. It looks... Okay. The buttons went to the side. Oh, gracious. All right, let me see if I can type this in. I just refreshed. That's when the buttons went to the side. Let's see if it'll work. All right. Now let's put the pi. Let's not talk about anybody's mama, please. Okay. All right, I got 4 pi. Are you guys getting 4 pi? Yeah. Okay. All right, questions. Do you maybe have these backwards? Do you have your 1 plus y first? I'll come look at yours. Yes. Did it give you a decimal though? Do 4 times pi. It's going to be the same. If you put a decimal in the problem, it gives you a decimal out. Yeah, so it's giving you the same answer. Yeah. If you need an answer that does not have a decimal, you can't put any decimals in the problem, because if the calculator has a decimal in the problem, it will automatically give you a decimal out as your answer. Yeah. Okay, assignment. Is it on there? Okay, here's your assignments. Just like we've been doing before, set them up. Use your calculator to evaluate, because it just takes too long otherwise. And that is it. That is all of our new material